Hi, hello. My name is Hajamato. Welcome to my video. In my video, I will be explaining the X-ray machine and the DNA transistor. Okay, and specifically, I will be talking about their working principles, their parts, and then the applications or uses, and then their general functions. Okay, to delay, I will be moving into my explanations. Okay, what is firstly I will be explaining on the X-ray machine. Later, we can move on into the DNA transistor. Okay, what is X-ray? Accordingly to the physics knowledge, to the topic of waves, X-ray is a type of rays that has the lowest frequency that travels penetrating to the human body or other materials for a short distance, and it cannot go for a long distance according to its properties. Okay, how X-rays are produced is simply when electrons from the positive side terminals of the X-ray machines are transmits or pass through electric field across to the anode side, and then they bounce off from metal called tungsten, and reflected rays are passed into a small gap or window, and then the rays that pass through are called X-rays, and this is how the X-rays are produced. Okay, let's move into the explanations of the X-ray machine itself. Okay, X-ray machine. Uh, Basically, X-ray machine is a machine that uses the X-rays, which is a type of electromagnetic waves that used to scan the unseen parts that our bodies, our naked eyes cannot see. And it is, yeah, it's the simple definitions to X-ray machine. Okay, X-ray machine has several parts to it, which I will be emphasize briefly on. Firstly, it has a cathode. Okay, cathode is a positive side to the X-ray machine. Okay, another opposite side to cathode is a anode, which is a negative side of the X-ray machine, followed by the seal balls, which is treated of leads. Also, the X-ray machine has some oil layers that found in between the different parts of the X-ray machine. It has a glass tube inside it that surrounds the anode and cathode. Okay, let's look again into the cathode. Cathode is cathode is created with filaments. Those filaments are used to send the electrons to the anode side. An anode is consists of the tungstens that used to rebound the electrons. Okay, how the this is basically the parts of the X-ray machine. Okay, now we will be looking into the working principle of X-ray machine. Okay, firstly, how X-ray machine work. Firstly, there is a voltage. This voltage is a power source, or yes, the current. It uses to push the electrons from the positive side X-ray machine to the negative side. Okay, the positive negative side contains tungsten, which when electrons go out there, they bounce goes into a small window, and then those small window, when the X-ray pass through, they bounce again from my film, and then that film is transmits the light into a view part that we want to find out, and from there the images are produced. Okay, applications of the X-ray machine. Actually, X-ray machine is used in the airport security for checking up the bags or any other baggages before transportation can be occur, and also in diagnosis of human bodies, specifically the fractured bones and some other parts. Also, they are used in mining industries for scanning the joints that there is to make sure that there is no other gaps in the heights, and yes, especially for the petroleum mines. Okay, that's all from the X-ray machine, and now I will be moving on into the DNA transistor. Okay, what is DNA transistor? Okay, DNA transistor is a machine that used to sequencing the genetic materials of humans, especially the DNA and RNA. Okay, DNA transistor consists of four bases. Two bases are found in the upper side of the DNA transistor, and then other two are found at the bottom. Okay, in the top of the at the top of the DNA transistor there is the two sides. So these two sides are consist of positive and negative. So in the negative side, the genetic materials are used to found there, and then positive side, the currents are found there. So the positive charge of the electrons, positive charge of the DNA transistor used to create a hole in the center of the membrane, which is called the nanopore, and then it uses voltage to move, or yes, is to move from the positive to go to the negative side and allow the genetic materials to move across that nanopore, and from that nanopore the electric field around there, so it used to hold the genetic materials inside that small gap. Inside that gap, this is that gap. That gap is a very small gap, so it allows only one strand of the DNA transistor. It allows only one strand of the genetic materials DNA to be moved into, and in that gap the sequencing occurs. And then when it moves, the transistor used to on and off to get the its parts of the genetic materials reading once, so that bases can be identified and the results can be recorded. And then its applications, DNA transistor is used in medical institutions and laboratories for identifying the basis and the origin of where the people are coming from, the ancestors. And then thanks for watching my video, and that's the end of my video.